And good morning. Good morning. How's everyone doing today? Friday. Oh, finally. It's been a week. I think I got everything going. We'll see. All right. We're going to do this again. We are flattening some widgets, or unflattening some widgets. We are absolutely unflattening widgets. So previously I was trying to use result pretty much in its entirety without using any sort of other stack to go along with it. Now, when we get to the top of the child of the widget stack, if there's anything, if there's only one element on the widget stack, or we're popping everything off and there are no children left to be added, then we should move them over there. So let's get the terminal case in first. Hey, Reed Rayner, how you doing? Good morning and happy Friday. How are you? Really good? Oh, wonderful. That's good. You have a good week? Oh, you started your own company last week. Ooh, very exciting. Very exciting. Kick my chair out of the way. Good morning, Xenocron. Interesting. I think I want to do something slightly different. If we want to match widget stack dot length and child count stack dot last. What are we doing today? We are working on unflattening widgets. So basically, we get this giant list of widgets along with how many children each widget has. So we've got a test here. So we'll have our widgets like this, and then the count of how many each child has, right? So something like these two lines here, where we have A, B, C, D, E, F, G, blah, blah, blah. right, with a count. So A has 3 children, B has 1, C has 0. We take a tree and we flatten it, right? And then it should become a structure like this. So what sort of company did you start? It's always exciting. Is this a nursery for something? Children? What? I feel like I missed something. I guess we could have done this as an if let sum, couldn't we? Yeah, we'd have to map it though. Do that again? Oh, this is actually incorrect. Here, this should be if let sum. No, I don't want it like that. 'Cause it's so in this case we'll get the stack. I'm just rewriting it here. Stack length and child count. Child count stack dot last. Oh, I'm gonna map that of some sort of value where we take widget stack dot length and v. I gotta get our tuple right. All right. Can we do guards on if let sums? You know what? Hold on a sec. We're missing our little friend here. There we go. Hmm. It's not it. So these are all on a match, right? So if the stack length is equal to 1 and child count is equal to 0, I'm trying to get rid of that double nesting there. Oh, hold on. So in this case, we actually want to take that widget stack and add that to the results. And in this case, what does this actually look like? Um, this would be something where, A has been flattened, right? And there's just J and K left on the stack. So we need to get all of those into a structure, into a widget structure. Oh, shoot. I forgot. I forgot that widget has this vector here that we have to basically collect into. Okay. We'll have to keep that in mind. Standard meme. We're going to take widget stack and replace that with the new vector. Okay. Yes, that should be a vector of vectors. Whoa, whoa. No, 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 not a vector of vectors. That's right. I just want to pop that, don't I? Pop that off the stack. Finished widget. Because the widget has children. Okay. Another if let sum. Yeah. Okay. So this is the terminal case where we've finished building it. Okay. Now, what do we do before that? Right. I'm going to go back down to the test case. We set some. Okay. How, what, and why? Yeah, absolutely. Okay, so imagine a page, okay? An HTML page, right? And you have different things on the page, right? Different um, logical items on the page. You might have a navigation, you might have some sort of hero element on the page, some sort of informational, like 2-column with an image and text, right? So you might have all these different elements on a page. HTML in its very nature is a structure. It's a tree structure, right? So you have one root element and you kind of tree out from there. Now, when we store this tree in a durable object, we don't just serialize it and dump it into one key value element, okay? Because when somebody makes changes to an individual element on this, I want them to make changes to a single piece in the structure. And I don't want to have to deserialize the whole thing, make a single change, like having to find it, and then put it all back. So what we end up doing is flattening the structure. No, I don't want to diff DOM trees. All right. We're basically going to be taking a structure like this and flattening it. Okay. And this gives us two things. This let's say we had 10 people actually editing the same page at the same time. We could actually lock each individual piece separate from another, right? You could be working on, component B, while I could be working on component E, okay? And then King can be working on component G, right? Even though G is inside of E, maybe, I'm doing something very specific to E, and these are two distinct things. So he can be working on G while I'm working on E, okay? Now, if it was just serialized into one giant blob, we couldn't do that, right? So what I'm doing here is separating the concept of mutation locks, right? Locks for that sort of yeah, just for the locking. I want to be able to not lock the entire page, but the individual element that you're mutating, okay? And I want to separate the concept of the structure from the individual elements so that, yet one other person, maybe Capitan, can be reordering things at the same time, okay? So maybe Capitan is moving I up here to be a child of B, right? Which requires no locks on the individual elements, only a lock on the structure itself. Okay. Basically, I'm pushing forward. I'm trying to eliminate the idea of having to deal with a conflict, right? We're trying to push that as far forward as we can, and this is as far forward as I think I want it to be, right? Where in order to edit something, when you go into edit mode, you basically acquire a lock on a widget. So if somebody else tried to edit the same widget on a page, they couldn't. It would come back and say, hey, Xenocron's got a lock on this widget, right? So that's what we're trying to do here. So I'm just not fond of letting somebody attempt to do something and then telling them, no, you can't do that. There's a problem with it. So each page is in its own durable object, okay? And each widget will have an ID. So the storage, when we store these flat lists, we will store the individual ID of the widget, okay? Now, each widget ID would then be a key in the durable object, and the serialized widget itself, which is just going to probably be a JSON blob, would be the value. So if we go back to an example of a page, pages slash, yeah, admin page is pretty good here because we have a couple elements. Now, you can see at this point we have a top level widget here that we call redirect. And this would basically be serialized out, right? And if we look down here, we'd have another widget and it would be serialized out except for its children, right? We're going to be removing the children from it whenever we go to serialize it. Because, right, the structure is actually serialized in a different place. So we'll give each one an ID. It doesn't have to go back to the browser. The browser doesn't care what the ID is. Actually, the browser might care because when we say, hey, give me a lock on this, we have to communicate what. So it'll probably bubble out in some form eventually. Yeah. It has something there. Probably something like a UUID here. Yeah. So right now we're trying to unflatten the list. And for unflattening, we don't actually care about the ID and the rest of it. All we care is that, well, we put the children back where we took them from. In our first attempt, the children were going back to the wrong parent. So it's a no-no, as every hospital knows. So is it only needed for rendering? Yes. Yes, it is. And that's basically what we're trying to get working here. Because we have pages, source pages. If you toss on the /edit at the end of a page and you have permissions, right, because our permissions are so awesome at this point, we would then ask the durable object for the page configuration as opposed to the key value store. So the durable object is going to be responsible for populating the key value store. And that's it. All right. So we have to remember that when a child can get added to its parent right away, or when can a child get added to its parent? Because a widget has a vector of children, right? It is a property called children, which is a vector of widgets. So let's think through this. Let's go grab a chunk of this. Just gonna grab here. That's a small set. Let's say we work through this logically. So A comes in. What do we do with A? We say, hey, A has children. Let's put it in the stack so that we can then, when we get a child, we can add it to A, right? So we put A in the stack. Oh, but then we have B, right? B has children, so we can't add B to A yet. So we put B in the stack. So now we have a stack of A and B, and that stack is this widget stack here, right? And whenever we add something to the widget stack, we also add the child count stack, right? So then we come through again. We say, hey, we've got C, and C has no children. It doesn't need any children. So at that point, we can add C directly to the thing on the top of the stack. All right. And then we have to decrement the child count, like the number of children that B needs. And then we come back through and we say, hey, B doesn't need anything else, so we're going to pop that and add it to A. So we add that to A, but we see, oh, you know what? A still needs one more. So we leave it there. We can't take it off of there yet. Then we come around, get another widget out of there. See, it doesn't need any children. Add it to A, decrement the count, and then A's finished, has a 0, and comes into this case. All right, there was a lot there. So if somebody manages to create a cycle, oh, that'd be funny. That'd be funny. I don't think it's going to be possible. But yeah, that's definitely something we should watch out for. Oh, what are we doing? Oh, great question. We are working on page serialization. I don't know if we can even get in this situation, Zenacron, because this thing is always going to be dealing with add this child to that thing, right? So add A to B. Oh, I see. But if B, yes, we'll definitely have to guard against that when we are doing the add widget pieces, but not here. So, Sandy Official, how you doing? Happy Friday. We are, we're working on our pages, okay? And what does that mean? We're working on something called mimeograph. So, a little bit of backstory. Oh, and Brooke. Brooke, welcome everyone, and thank you for that raid. How are you? So, good timing. Good timing. We were just going to explain what we're working on. So, and I hope your stream went well. Happy Friday. I'm looking forward to this weekend. How about you? So, you have zombies that are attracted to humans. Oh, that's great. That's cool. Now, so in mimeograph, let's see if we can pull this up. Let's kill some of those. All right. Let's see. We want to go to mimeograph dev slash login. So we have pages, right? Pages that look like this. Okay. And there's a structure here. So, right, we can see that there's some sort of background, and if we log in, don't say. Then we can go to the admin section, which is a little bit more complicated. You can see that there's a header, there's this flash message thing, and then you can see that there's different tiles in here for admin related things. All right. So you have this page structure, and in order to be able to store the pages, we actually flatten the tree structure. Okay. So this is a little snippet of what a tree structure could be. We have A that has a child of B, which has a child of C, right? And D is a child of A. Okay. Now, given some data that looks like this, right? Make the tree structure again. So we can see that A has 3 children. Well, in this case, because E is also a child. So A has 3 children, B has 1 child, C has 0 children. Okay. So we're working on unflattening. So we need a couple stacks. And really the purpose of being able to unflatten these, or to store these things in a flat way, is so that when people are editing the pages, you can have multiple people editing a page at the same time, but the locking is done on a widget level. Okay. So if the widget has children, add it to the stack, to the widget stack, and needs children, requires children. One vector widget RC widget. Place the vector of the children. Probably. Yeah, that would work. I like the challenge of the stacks though. And I think we can do this with fewer allocations here too. I know we're going to basically have um, some allocations, right? Because of these vectors, but they should only grow to a certain size. And once they're at a certain size, then we're done because we basically reuse them. Yeah, this whole thing is just full of allocations actually. So why am I worrying about it? Because each one of these widgets has children, which is yet another vector. So, yeah. Oh, the vector RC widget thing is very interesting. Huh. Yes, widget contains a vector of widgets. So it's a tree structure, right? So you have a widget that contains a widget that contains a widget. Hmm. Am I sensing a Y here? Like why do we even have to do that? When would we ever call on flattened widgets? We would only call on flattened widgets when we went to serialize this to send that back, right? So if we needed to send the structure, we'd have this. Where's our hierarchy? So we have this get function. We get the hierarchy, we get the widgets, then we send the widgets back, which we're not doing yet. But why do we have to put it into a hierarchy in order to serialize it? I hear you say. Good question. Because it was already done that way? Can I do partial renders? Yeah, I could. We could. But then we would need some way to be able to. It's funny because our partial renders result in a JSON structure. So we basically have to serialize this out and then do just string concatenation. But you're absolutely right. It's very similar to what we're doing for the page rendering, actually, except we don't have to wait for futures in this case. I'm not worried about performance in this case, because if somebody goes into edit mode, if they have to wait another 10 milliseconds for a page to show up, that's okay. They're in edit mode. But I think the complexity is still there if we render to text and then have to store that and then put that into the parent at the right place. It's basically the same problem. So when we ask for the widgets, yeah. Well, let's just do this because once we have a widget, we can just serialize it. Once we have this all in a page, we just render that back. And all of that machinery is there. All right. So if it requires children, we add it to the stack because if when we get widget A, we check to see, do you require widgets or not? Children. If you do, we need to push you into the stack in order to later add them to you, right? Because they might require children. So if that's greater than 0, no. We always push you on the stack because later we'll check to see here. If you're a rare case where you're just one top level lonely widget, you'll get added and then removed, just to simplify the logic. So child count stack.push, child count. Oh, num children. Widget stack.push, widget. Now the comment's wrong. Um, So we add it to the stack. Now if it doesn't require any children, we come through into the terminal case where we get the child count. Right. If there's only one thing in the stack and it doesn't need any children, we basically take it off of the stack and push it into the result vector. Then we come around again to B. Now for B, we check to see, does B need children? So we add it to the stack regardless. Which is fine. And we see that, yes, you require children. All right, so now we have on the stack A and B, right? So our stack is A and B. A2, B1, okay. Plus the count, right? The number of required children. Now we have C. We come through again, we get C. C requires no children. And we push it onto the stack regardless. Now when we get to this point, we can actually take C and put it on B, right? Because B needs a child and it requires a child. You're off to work. Well, thank you for dropping in, Brooke, and thank you for that raid. Have a great day at work, everyone. Yes, and to you too, Brooke. So at this point, we have C0, right, on our stack because we pushed C onto there. And the child count is 0, but the stack length is more than 1. Okay. And it feels like this should maybe be in a loop. something else. We'll get to that in a moment. Because if we need to keep popping things up and off, I think we need to loop this. Oh, and Taylor Fraley. Thank you for that follow. All right. We'll get to the loop in a moment. So if it's equal to 0, then we have two cases inside, right? One where the stack length is 1, where it's the terminal case. The other case where it's not equal to 1, where we can actually add it to the parent. So let's move this in here. So we're going to have different versions of this. I don't know. It's kind of an if-else. I don't want to match on that. So if it's equal to 1, otherwise, top level widget is finished. Move it to the result stack. Okay. And at this point, we would break, right? If we were inside of a loop. Child count, stack length. Okay, so if the stack length is not 1, right? That is correct, Zenocron. That's correct. All right. So in this case, we're going to still pop something off the widget stack. Because in either case, we're going to be popping that off. Maybe we should take that out. Push that out here. Actually, is this always guaranteed to be something? Widget stack, yes. Yes, it is. So we could actually unwrap this. There we go. Okay. So the widget requires no children. It can either get booted into the results or onto its parent. In a sec. Let me check some messages. Why does, so we're talking about programming languages here. Why does the C programming language get all the dates, get all the girls, and Java gets none? Because C doesn't treat them as objects. Didn't. I just saw that one. Yeah, I know. Sorry. Ooh, because C is classless. I don't know. That one went sideways. All right. All right. So coming through this again, child count 0. Take the widget off of there. We're going to put it on the results. Right, if the stack length is 1, meaning that there is no other parent that we can put it to, put it on. If there is a parent to put it on, then we add it to that parent. So let parent equals widget stack last mute unwrap. Now I'm adding these unwraps here because I have visually verified, like I have logically verified, analyze the code, and know that there is at least one parent here, right? Because we've checked stack length. Well, I guess we could say else if it's greater than 1, but this shouldn't be able to skip the 1 step, right, as we go down. So we know that there's at least one parent. So let's document this. At least one widget at this point because we popped it right to parent. Oh, was this true then? No, we could have stack length is equal to 0 there. Right, because if we pop that off of there, then it actually goes down to 0 at that point. Oh, I'm glad we're checking this. A little off by 1 error. All right, so there's our parent. And the parent, we're going to push that child onto it. What's it called? Widget? All right. Here, right, we've gotten to the top level. There's no more. Or if there are still more children to add to this stack, here. So this widget stack requires more children. Okay. So let's look through this again. We've got, I'm gonna. This is our structure here, A, B, C, right? With in that structure, right? C is a child of B, B is a child of A, and D is a child of A. So we come through there. We add A to the stack. Oh, we are not popping the count off when the count gets to 0. See that? We're pushing some things off of there. But when we pop, we also need to pop the child count stack. Is there any other pop? Less mutable. Nope. Okay, we only pop there. All right. So we put A onto the stack, right? Then we come in here into our little loop. And we come into the loop, mapping this, right? Because we get the child count stack last. And we add length to that. Why did I do it that way? Because I didn't want to assign length to some. This looks like garbage. Okay. Ta-da! All right. That looks so much better. All right, so we still have A on the stack. We come through here. We get the last element on the child count stack, not popping it, just taking a peek. And if let's sum the child count right here, right? So if we do have one, and if the child count is 0, then we pop it off the stack and the number. Okay. If the stack length is then 0, right? So if it basically requires no children, meaning we've reached a leaf node, right? We're going to add that leaf up the tree. So of our widget stack and our child count stack. And if there's nothing else to add it to, right, that leaf is all alone, that's a result. We add it to the result set. Otherwise, we grab the parent and toss it onto the parent. But we're forgetting one thing here. We need to decrement the parent's child count. Child count stack dot last mute unwrap. What is pointed to by parent child count minus equals 1. Add the child to the parent and decrement the parent's child count. Great. So I haven't gotten past A. I just saw the error. Okay, so we're going to reset one more time. Hopefully we don't have any other errors in here. All right, so we take A, put A onto the stack, come through here, check to see child count. Do you need children? I don't know. It always sounds so weird when I say, do you need children? It's like, that's a little creepy. Do you require? Oh, thank you, Cryptrix, for that follow. You might want to rethink it now. So we get into this child count here, and the parent widget node requires a child node. I don't know. It doesn't make it any better. All right. So A, at this point, requires children. So, and as a parent, man, it's weird. So we require children. The child count is more than 0. We break. Okay, we're out of the loop. Now we get into here. Now we have widget B. We're going to add something to our stack. B has a need for one child. All right. So come through the loop. Stack length, child count. Nope, it's 1 right there. There's a 1 right there. So we skip that one and we get into the break. Simple. Yep. Now we got C. Let's put C on the stack. C 0. C would come through. Child count 0. Perfect. Widget stack pop. Boom. C is gone. So widget is currently C. So we take those two elements off the stack. They're stacks, plural. If the stack length, the total, like this, the length of this here is 0. Nope, it's more than 0. Oh, actually, this Clippy is going to be pissed at me. Is empty. Do I even need stack length at this point? No, okay, we get rid of that. Widget stack. All right. So we've just taken C off of there. This is C at the moment. If the widget stack is empty, it's not empty yet. So in the case where it's not empty, we grab the parent. Oh, we grab the parent. And we say, stop losing your children. Here's your child. So we push the child upon the parent. Decrement the parent's child count. And we keep going. All right. So we forgot to decrement. There's our decrement. Now we come through this loop again. Because we did not break there, we come through the loop again. And we get the child count stack, right? The last element, that's B. Oh, excuse me, that's 0 in this case. If child count is equal to 0, can I just unwrap this? Do I actually need to know? Hey, you're new here. Jesus work. Good morning. Have I made code for render engines such as Blender, Unreal Engine, etc.? I have not. No, I would rather make a game than make an engine. Right? I'd rather be the storyteller. I mean, we've created lots of code, and we've created like procedurally generated islands and stuff like that. So much more on the storytelling side than the render engine side. Is this ever going to be the case where this is not set? Because we always add something to it. Well, except for the loop, right? Guess if we should always break, shouldn't we? Because whenever we pop something off of this, it's either getting pushed onto one or the other. I think we can actually unwrap this because we're going to break before we get the child count stack not being 0. I don't know why I'm focusing on that at the moment. Anyhow. All right, so we have B. B has 0 children at this point because we're working up this tree. So we come into the else here because child count is 0. Come into here. Decrement the parent child count and take that off. Add that to the parent. Get rid of that. This becomes 1. And then we come through with 1. And child count is not 1, so we end up breaking out in the else there. We come through here, the for loop again, and we end up getting the next element, which is D. Now, D comes through. Let's add D. D0. Yeah, I think this will work. All right, let's test it. We'll test on flatten. Failed. BE. All right, let's grab this. Take this into the browser. We have here. AOU has 3 children. B, D, and E. Is that not correct? Here, I'll bump up the font here. So we've got our object, and A has B, D, and E. Let's go back and look at our test structure. Here's our tree structure that we're trying to set up. And A should have B, D, and E. So, and then B should have C. And its children is C. Oh, wonderful. And C has no children. That's looking pretty good so far. D has 0 children. Z, okay, good. E should have 2. Let's go look at E. Where's E? Here's E. F and I, and F has 2 children, G and H. That looks like it's working, which means that our test is wrong. On line 174, 174. Oh, because we're popping off the end of the stack. That should be E. Am I familiar with hyperbolic function? Hyperbolic function. I'm not off the top of my head. Is this for... Oh, yeah. Goodness, it's been a long time. Yes. It's been, oh, so long. Is this for a rendering engine that you're asking about this? So that's going to be E. E is going to have 2 children. And if we're popping them off of there, E is going to have I. E. All right, there's E. Well, E begets I. All right. And then after that, E. Well, what was it? D? No, F. F. And then F gives us G and H. So H first. So we get D, which is alone. And D comes from A, right? Does not need to be mutable. Do I do freelance work? No, not at the moment. I have in the past, but not in the last 5 years. Oh, and thank you for that follow. Is that Ren Garrett? All right, so there we have D. We're just gonna finish wrapping these up. Now we need B and C. B, A gives B, and then B gives C. Oh well, there's C, D, E. Okay, so that should give all of that, and then we already checked the J and K at the very bottom. Okay, did we get that right? Ah, correct. Ren Garrett. Happy Friday. Oh, could not compile. Why? Oh, it's not mutable. One more time. Cast, look at that. There goes our unflattened function. All right. So unflattened widget is working. Good. Anything else we need to do in there? Clean up some comments or anything? Looks pretty good. Oh, yep, return result. That's there. Okay, now let's call this function. Oh, let's move the test down. What is the end result of this? Adjacency list. Ooh, technical Xenocron. Thank you. Yeah, basically we are working on the deserialization. So a page like this, which is a tree structure, is stored as a flattened list. What it is, kind of? Yeah, it is. Yeah, that's. Yeah, thank you for that term. So we take a page that looks like this, right? Because this page here is described by this structure. Okay, it's a big JSON blob, and our widgets are here. And you can see that there's children within children within children, etc. Right? And we basically flatten those when we store the data. Okay. And we're doing that because we wanted to push forward as far possible conflict resolution. So if two people are editing the page at the same time, this being like a WordPress alternative, you might have a situation where you have multiple administrators editing, let's say, the home page at the same time. And you wanted to be able to say, support that without having to deal with conflict resolution. So in this case, we've constructed this such that two people could work on this page at the same time. Well, three people could. Depends on how many widgets you have. And they could each individually edit a widget without interfering with each other. So we just constructed the unflattened portion of our widgets. Yeah, because when two people are going onto the page and they both click like the edit button for a specific widget, right? The first person, like if they're trying to edit the same one, we'll have some little locking mechanism that'll say, "Hey, you can't do that." Mr. Halsey already has a lock on this widget. But if they're different widgets, so we're reducing the footprint of the lock as much as we can. Um, We could even have people rearranging the widgets while people are editing the widgets, which is just crazy because we're storing the structure separate. So we'll be able to lock the structure separate from the rest of it. Really, I think the only piece that's going to be a little odd is deleting widgets. So let's say somebody's editing a widget. I guess we shouldn't allow anybody else to click the delete button at that point, which seems reasonable. So it'd be the same process as getting a lock. Yeah, that still works. Okay. So coming back to where does it get? Here's our get function where we need to get this config. We ensure that the durable object exists. We're using Cloudflare with Cloudflare's workers and their durable objects and the KV store. In this case, we're using the durable object. We're within a durable object. So similar to please log off your other device kind of thing. Kind of, yeah. We're basically pushing the conflict resolution back to a social situation. So, let's say I had something locked and open, and I went home for the day. Right? You could break the lock, right? Because we'll have support for that. We'll say, no, I know that Halsey isn't doing anything on this anymore, so I'm going to break the lock, right? And then any save or whatever that Halsey does is going to be rejected because you would have taken over the lock. So we're trying to reduce the space as much as we can, but still allow for the social sort of situation where you might be able to call me and say, hey, are you still working on that? I'll say, oh, no, I forgot to close my browser. I went home. Or I closed my browser and went home without releasing the lock. We'll have some sort of timeout, some realistic settings, right? You found Rust difficult. Oh. Yeah, it's got some learning cliffs. Yeah. It's a really nice language, though. Oh, and thank you for those follows. Banzi and Jace's work. Thank you. So in this case, we get the hierarchy, and then we get the widgets. Goodness, when it rains, it pours. Our Transat, thank you for that follow. Now, so we get the storage, we get the hierarchy, and the hierarchy is saved in 3 fields in a durable object. What is the next one? And if we go to using UUIDs, that's going away. Why should you never fall for a tennis player? I don't know. Why? Because love means nothing to them. Oh, bravo, bravo. How long have I been doing Rust? I have spent, oh goodness, nearly 2,000 hours learning Rust. Oh, you like my serverless stuff on YouTube? Oh, welcome. And sorry for my infrequent uploads to YouTube. I was actually about to do it this morning again, but I think I'm 7 uploads behind. Welcome. Yeah, we're still doing serverless stuff here. Oh, nice, dude. We've got to capture that one. And let's see, where's our notes? We have been collecting good jokes and bad jokes, mostly punny jokes. And we are going to have our bot Capitan eventually tell jokes. So, Nightshade, dude. Oh, let's see, we got another one here. Why should you never fall for a tennis player? Oh, and Alexi. Is that How do you want that pronounced? What am I doing? How do I calculate hours of learning Rust? Well, I have learned Rust on stream. So I started September 14th, 2 years ago. And so Twitch keeps track of it for me. And I think I'm at 1,800 hours on Twitch, and I've got a couple hours outside of Twitch. But yeah, it's like my hobby. I just love learning Rust. Oh, let me grab this. All right, why should you never fall? Sorry, I'm a little off my game here this morning. Didn't. All right. No, I want to paste and match style. Thank you. Whatever. Because love means nothing to them. That's beautiful. All right. Yeah. So in my achievements on Twitch, and this is so whenever like I say, oh, I've been doing this many hours, etc. Right. So for those of you that aren't streamers, right, you have all these achievements and stuff in Twitch, right? And these are, it's just kind of a gamification thing, but it's not really what I was going for. But they do have all these things. So some of the interesting information here is like this. Like, it looks like I just hit 1,800 hours streaming, right? So I get another achievement when I hit 2,000 hours total. That's fine. Or if 25 people say something, right? We unlock additional VIP badges. Cool. 250 viewers at the same time. I've only ever hit 216. So it's interesting, but yeah, it's just fun. You too. You finally found where you can learn it better. Found Valorant, a game written in Rust. Which very cool. Yeah, nice. Yeah, I've been watching Valorant. It's a neat game. Almost to the point where I actually want to get it set up for me and my kids. I think that'd be a lot of fun. All right, so here, when we ask for the config for a given page, we get the hierarchy, we get the widgets, right? So getting the widgets is basically loading up all of these things. Apparently, we have a to-do here. What's a to-do? Oh, because we're supposed to call flatten, unflatten widgets, the function we just wrote. So we're going to pass in flat widgets and the children. Where's the children thing? Total widgets. That's this value here. Oh, so we get the page hierarchy. So it's page hierarchy dot something. Okay. Here. Dot children. That should return a vector. What does this want to return? A result to an option to a widget. Which is incorrect. Okay. Yeah, this should be a vector. Vector of widget. Because if it ends up being nothing, we have an issue. So let's wrap this in an okay sum. Do we use none in this case? I think we don't. So why even see? Oh, I didn't think about that. What if the widgets is empty? What do we return? Just an empty array. Okay. So yeah, we don't need sum because we'll have an empty vector passed back instead. So no option. Hmm. Cannot move out of heart. Get out children, which is behind a shared reference. Oh, touche. Do we need that anywhere else? I don't think we do. Next flatten how many? No, that should just take it by ownership. Let's own that. And now we can take that apart. Okay. Great. Now we have widgets. We're so close to being able to respond here. Oh, at this point. Going on over here. We're good. Okay. Now the config we want to send back is going to be a page config. So we need to fetch a few more pieces. So if we go to where page is defined here, we need some more of these. So we have serialized widgets, but now we have scripts, style sheets, embedded style sheets, description, lang, title. Right, so now we need to take those and be able to create some sort of page with it. All right. So with widgets done, it's going to be another async function. Get page. We'll give it the widgets and storage. Okay. Let's put this next to the get widgets. Underneath it. Let's see. Async function. Get page. We receive widgets. We own them. And storage. Durable object storage. What should we return? Create result in case something fails. But a result to what? A page? Let's see if that works out. We need these elements here. Whoa, whoa, whoa. Come back, come back, come back. There we go. Does this have to be... I think I'm missing something here. When we ask for something from storage, we actually have to give it... Not that. It has to be a JS array. JS array. That doesn't work on array, does it? Not yet. We're going to map those into JS strings or JS value. Then we collect it. Oh, that's a vector. Okay. And what we should eventually return is OK to a page. And a page has a number of properties, which we'll ask this to fill in. Good. All right, now we need some of those properties. Great, these one at a time. What is expected option found vector? Huh. And I'll find that. Okay. Fine. It's an option to a vector. I keep flip-flopping on this. Why would I have an option to a vector? Because a vector doesn't allocate unless you you force it to have some size. Why wouldn't we do that? 18. Oh, that's a false. Did I get that correct? None is empty. Yeah, none becomes true. Some becomes false. And in this case, we can do self.widgets extend. Oh, other.widgets. Clean up some of this. Well, in this case, we could combine these. Oh, we want extend? Why would we only do... Why would we insert... Oh. Was that incorrect before? Ooh, interesting. We need index? What do you mean we need index? Because in this case, we are extending one page from another. So the other widget basically gets extended onto this. Oh, oh, oh. But now self.widgets is always something. So that's what the difference was. Because self.widgets was an option and we inserted the other into the option. But now that they're both vectors, we can extend. Guess there's an optimization we could do if we wanted to. And that if the first one's empty, we could just use the second one. We say, hey, just replace this. Oh, yeah, we're not using insert. Insert was because it used to be an option, but now we're using a vector. And insert on an option just puts something into the option. So yeah, there is a case here where we're missing an optimization. So if this is the case where the first widget, the thing that's going to be consuming the second one, right? Because we're extending self with the other. So if self is empty, let's just standard mem replace self dot widget with other widgets. There we go. Oh, core. Oh, Alec. Huh. Guess it makes sense because it's not. What you end up swapping out might actually be on the stack, huh? It's not always Alec. There we go. Now in this case, we are calling build widgets, and we're trying to take the element out of there. That's why we had the option. We'll basically do a take. There. Mismatch types. Option. You now take a vector. Thank you. Which means that we always have widgets. Which simplifies some more logic. Okay. We get rid of those and that. Basically, we just create the result, skip the loop, and return it. So that's fine. Anything else? Nope. Now we're back up to page object, and we have decided on using widgets. Thank you. On vector instead of an option to a vector. All right. I don't know which is easier. This one? Hmm. So we now have this JS array full of JS values that represent these elements here. If we go back to durable objects, whereas here, we're going to list these. So we're going to pass in an object. No, we want to get keys array string. There we go. This one. Good afternoon, I Heart Coding. How you doing? And welcome. Happy Friday. So we've got this array. Do the promise map. So we need to get this map back, and then we'll take these keys out of it. If we don't have one, we will default it. So we've got, what, 6 elements we need to take care of. Let's call storage object.get for that. Storage.get. Get to all props. Good morning, Dad. What's that? Here. That's right. It's JS Future. Oh, where are we now? Let's go back. Sorry, jumping around too much. Here we are. So get all returns a result to a promise. Then we have to JS Future that. Wrap that in a JS Future. Await the result of the JS Future. We're going to get a map back. And the map needs to be... we can do that inside, outside. Inject into. There's our map. Okay. Now what can we do with a map? We want to get elements out of a map. See, we end up calling get, and it'll give us a JS value back, but it might be undefined. So if we ask if it has it first, then we can get it out of there and not do the undefined check. I want to use reflection, but we can't. All right, so if the map has title, title is going to be let title equal to this. There. So we'll have one and the other. So this is the default. This is the actual value. Hmm. And who wants it borrowed? Okay. We good? We good? There we go. So we check to see, do you have this? And if you do, we're going to get it. Hmm. Hello. All right. All right. So we have title stir there. So we get that. So that should return JS value. And that JS value we need to convert into a JS string. Well, into a Rust string, excuse me. Into a Rust string. Because those maps, let's see. The type of each return value in the map will be whatever was previously written for the corresponding key. Any keys that do not exist will be omitted from the resulting map. Which is why we're doing the check. Supports up to 128 keys at a time. It's fine. So in this case, we get a JS value back, right? JS value. We want a string. Yeah, and then we can go into the other. Okay, title done. Now we basically do the same thing over and over and over again. Let's take this into a macro or a function. I guess we do a function. Be a little smaller. What are the, I mean, language is going to be similar. Description, that's also a string. So string. Style sheets is not a string. So, yeah, whatever. Let's stamp this out for a moment. We'll clean it up. What was it? Title, lang. Description. Embedded style sheet. So then we have these three. So we could definitely put those up into some sort of function, right? Oh, my wife sent me a link. How to milk a goat? What is this? Guaranteed monthly income for life. Quick, quick, quick. Come on. Uh, so let's see. What do we have here? I'm gonna milk a goat. Inline filter. Huh. Got the sock and a spring. All right. I'm gonna skip that one. Watch it later. She wants goat. Well, we have goats, right? We have goats. Oh, uro niwa. We miss you. All right, let's make a little function for getting a title out of a map or a string out of a map. Do I have anything like feels like there should be some sort of utility functions for maps for this. This map is such a pain to work with. Just because of the JS value bits. All right. Do we have object get? Oh, and thank you for that follow. Rattlehead. How are you? Happy Friday. Oh, and we got glitter. Glitter stuck in the screen. There we go. So what's going on here? Why do we have this? So anything that supports JS cast, so we get a JS string out of there, an option to a JS string for JS's map. Hmm. I Oh, and then we have it for object as well. Where's this used? So and this will give us anything that supports JS cast. And if we look at what supports JS cast, JS cast, JS can't, JS cast. Where's our list? Import JS cast for JS value. Oh. Where's our giant list of other things that support JS cast? Where's our foreign types? So I know that these support it. Basically numbers, strings, a whole bunch of other things. Basically things that deref into JS value. Or asref, is that what it is? Asref into JS value. I think I'm going to rename object get into something else. Okay, so we'll have that. Implement that. Now this is going to be, goodness, near identical to this object get. We basically call object get, right? But we want to cast into a JS string. And then we get a JS string back and can then map that. Self.get obj. And that's going to be a JS string. Map. We're going to map that into. Oops, that should have been a string. Cannot find string in the scope. House prelude on there. Now we have string. Okay. One more here. Oh, expected one argument. Oh, we need the key. There we go. Just a little utility function. Well, why don't we have a default impl for this? Right? I mean, basically we're just getting the object and we're calling getObj. Done. Okay. Let's go back to the page. I'm going to replace this. Let title equals map.getStir. Look at that title. Unwrapper default. Done. So much easier. Lang. Description. Oh, that went poorly. All right. There we go. All right, now we need embedded style sheet. Style sheets. Are these both the same thing? Vectors? No, option to a string. All right. So if that's just an option to a string, we don't have to do the unwrapper default. There we go. Done. Style sheets. A vector to style sheet. And what is a style sheet? It has properties and stuff on it. Okay. We're going to need serialize on that. And on this. Because we're going to have to serialize this. Not on page, though. Just on style sheets. Actually, I'm not sure. I mean, what do we do? What does it do? If we take this to a value, it's going to be an array of these things. We take it back from a value. Yeah, okay. So for a style sheet, That's going to be map.getObj. This will be an array. Now it's an option to an array. Okay. But we need this as a vector. We'll map that, taking the value from value, v, option to a style sheet. Oh, we've got a little bit extra. Okay. We end up mapping that into a result, which we could then, it's an option to a result, transpose it, take that off. Okay. Actually, do we even have to do that? Can we just call get on the object? Yeah, we just, but then we have our silly JS value thing. But what if it's undefined? We don't deal with that. This wants a reference. Get returns a JS value. From value returns a result. And at this point, we don't know whether or not it's optional because we didn't do the check to see if it's undefined or not. I think I'm going to go back to the previous version here. Because at least we get the option. We know whether or not it's undefined. So we just have to take v back down to a value. Can we just into on it? We might be able to. Yes. Expected vector. What? Oh, yes. It's just vector of style sheets. And scripts. Basically the same thing for scripts, I think. Unless it's strings. Vector of script. Okay. Okay. That should work. I wanted to check on durable objects. I wanted to see list one more time. Returns all the keys and values associated with the current durable object in descending lexicographic order. That's all the keys. I see. Not values. All right. So, I've got that and that. And we return a page back. Really? Okay, page. Who's calling get page? Here. So now at this point, we have to serialize this to JSON and send it back. And in theory, this all works, right? Except we don't have anything stored in that durable object. Huh. Well, building it up. All right, so we've got our page. It's funny because now I need to take that to value. Why don't I just deserialize that if I'm just going to serialize it to make sure it doesn't have any errors? Yeah. All right. So body is going to be JSON stringify a JS value to value page. That's a result to a string. Okay, now we have a JS string, and this has to go back into a regular string. Page doesn't serialize yet. Okay. Set the body. We need to set the response to. Status 200. What does that take? A U16. That should be fine. What am I missing? Oh, stats. Status. That didn't save. There we go. All right. Let's run it. Ah, I get this working. All right. So let's go to the admin page on localhost. Here we go. Now if we go to edit, that's going to be our other flow. It tells us actually that page is not found. Unexpected end of JSON input. What? Because it was empty. Our body's empty. Oh, random ID. Thank you for that follow. Let's try again. I'm guessing that it just doesn't like the body being empty here. Because the durable object just doesn't have anything in it. Which means should have come back to the state here, right? Uh, I I don't see our log because we're not logging. Do I not have a? Oh, there we go. There's tail. It's in the durable object, so we have to run wrangler tail to be able to get the logs from the durable objects. It didn't do anything. Oh, actually, because also I didn't publish, did I? That's right. We have to upload that again. So I have to restart that script whenever I want to make changes to the durable object. Basically, I have to publish first. Wait, does that actually publish? No. There we go. Now we can run dev. Okay. Run that again. It's now prepared to stream logs. There's an amazing amount of nothing. All right. Well, how do we handle that? This has been the challenging piece of working with Cloudflare's durable objects and their workers, is that you'll get something simple like this. And part of this is because I have stripped out some of the stack trace for size reasons. You can see our WASM file is currently weighing in at 339 kilobytes. So we've got a little weight to it. But this must be empty. I can't believe it's just not logging. What is it actually doing? E and V. So it's getting the correct environment and config file. Okay. But it's not doing pretty mode. Format pretty. We definitely want the pretty one. Let's log in one more time. Evil Halsey. Go to the admin area. Good. And edit. Nothing. Hmm. All right. Well, hopefully it's actually returning the 404. And then we can go back to pages here. Because in this case, we get the do load here. And you can see this is where our AOUs are. So if you see up here, all right, we get 1, 1, 1, 2, 1, 3, 1, 6, then 2 and 3. Hmm. Why didn't we get 4? Did we get 4? No, we missed 4. We got 1, 3, 1, 6, 2, 3, but not 4. Which means we went over here. Let's double check that. So if we get that error, what does that mean? That means that the JSON, oh, the promise from the JSON failed, which is exactly what's happening, right? That's where we're getting that error. That's why it's printing out that. Fetch page config promise failure. JavaScript error, unexpected end of JSON input. Response was good. Yeah, that's the error. If actually, if it's not okay, 404 is no, we're not. No, no, no. We just want to know whether or not it was a 200, because if it's not, we will return none. There we go. AOEU none. And we got a 404. Perfect. Now we have to put stuff into that durable object. How do we do that? How do we do that? Feels like we need to start building out some of the other API pieces so we can start to import our page configs. Either that or just have an import function. So we do like a post, like something like that. Read in some JSON, flatten it out, store it, done. Right. That would give us the ability to migrate all of our JSON files that we currently have. Hmm. So yeah, that's probably the best way to go. Because if we didn't do that, all right. And lucky for us, we've now got this postfix set up. We do something like this with a put. It's more of a post, isn't it? So if we import to a given place, we'll do load on that. We don't want to do load. We actually want to forward this request on to the durable object. Okay. Back to lib and wire that up. So we need to first make sure we do a little security check on that. We don't want like ornery people like doing stuff here. We need to check the session. Was it cookies or cookie jar? Access to the cookies? I forgot how the session stuff works. Um, Session object, email and enroll from cookie. Okay. So in this case, we have sessions available. Oh, this is late. This is actually in template stuff. Okay. We'll want this early here. Because we're not actually going to call template render. Right. None of that. Five. 1, 2, 3, 4, 5, 6, 7. This needs to be 7. Almost. 7? 7? Nope, almost. Good. There it is. Okay. Feels like this should be kind of a nice little function off of event. Like on impl event. Storage. Yeah, why not session? Oh, because it can fail to. Let's just do a result to a session, and we'll still use the default session. Why do we have to await that from cookie? Oh, the crypto stuff. Okay. And this should be a little different. We don't need a map there. A match. We need a map. And let's call it S for session. We can't await in combinators, can we? No. There we go. Let's go back into pages now. There we go. Session. It's only allowed inside an async block. Yeah. All right. It doesn't matter. Um, okay, so we await that. If it comes back and we have a session, we can check permissions. How? What do we check? Session dot roles dot can permission. Okay. And this is going to be owner. So anything. Okay. Guess we just need another permission. Page import. Missing match arm. There we go. In roles. Fill match arms. So admin. I'm going to say return false here. So unit instead. Okay. Only owner can do that. Oh, and they're not sorted. Okay. All right. Now that we have all those sorted, do we have any others? Expecting match arm. Okay. What is this one? Display. Oh, okay. Okay. Is this? Hmm. So if we can't do it, let's set. What do we want to set here? We want to basically say that this was not handled. Um, router result not handled event. So we pass that back. Okay. It's gonna be tough on the permission check on this because template render. What's that going to look like? So if we did that, right, then yeah, okay. Page edit. That one's done. Now what about this? So if we have data coming in here, we have an event, we have a request object. Can that request, let's see, that should be, what can we do with a request object? We want the body off of it. We just want to post JSON. So why didn't I use this here? Form data. Side trip. Because we have post data. Yeah, fix me, yeah, whatever. See, we should just call this form data thing. Or was there an error with that? Because yeah, we basically want to be able to handle the multi-part form data. Oh, but we're not. Looks pretty good. I work at McDonald's. Welcome. And thank you for that follow. It's time for some water. We are running low. One down. One to go. Wonder why I didn't use multi-part form data here. You're always forgetting to drink yours. Yeah. Gotta do it. Well, I gotta get going. Gotta get ready for work. So, we're going to set up a raid. Going to use Museum's tool for figuring out what we can raid. Not many rustations out there streaming today. Let's see. All right, we're gonna raid Tej. Tej works on Neovim. So. Oh man, well, that's good. We got a lot done. We got the unflattening working, which is great. And now we need to be able to put data into it. So next piece, importing, and then on to actual editing stuff, which is exciting. That's gonna be nice. All right, till next time, y'all. Happy Friday, and bye bye.